Okay, today we're doing section 5.2 and it's piecewise functions. A piecewise function, all it is a function with pieces. Each piece has a different constraint or rules that match it. So if you look at the graph, they're just pieces of graphs. That's all. All right. So here's what we're going to do. Let me get a white pen. So this has a U graphing. The graph of f of x equals x minus 1. And the piece of that you're going to graph is all the pieces where x is less than 2. So we're going to make a little table for that. We're going to pick x values that are less than 2. So we're going to keep that 2. We're going to pick 1 and 0. So we're going to plug that in for the equation. This is the equation, so we're going to plug x in there. So 2 minus 1 is 1. 1 minus 1 is 0. 0 minus 1 is negative 1. All right, so let's go ahead and we're going to plot that. Oops. We're going to plot that point. So it's less than. So we're going to start at 2, 1. So 1, 2, and we're going to have an open circle. Then we're going to plot 1, 0. Then we're going to plot 0, negative 1. Here's our first one. Okay, so now let's go to our second equation, which is f of x equals negative 2x. And we want all of the values where x is greater than or equal to 2. So we're going to make another table. We're going to pick x values that are greater than or equal to 2. So 2, 3, 4. And we're going to plug them into the equation. Negative 2 times 2 is negative 4. Negative 2 times 3 is negative 6. Negative 2 times 4 is negative 8. So now, if I can get another color here, we're going to plot that. So I'm going to start at 2, negative 4. This time it's going to be a filled in dot because it's greater than or equal to. Then I'm going to plot 3, negative 6. And then I'm going to plot 4, negative 8. There we go. There's your piecewise function. Now here's the tricky part. The questions that are below. So over what intervals is the graph increasing? So we're looking from left to right here. When you are moving left to right, what intervals is the graph increasing? Okay, so if we're going from left, we have negative infinity, and then it increases all the way to here. It increases from infinity to here, which is 2. And this is not like the interval notation. There's no brackets. This is just telling you the intervals over which it is changing or increasing. So there are no brackets here. So over which intervals is the graph decreasing? I'm going to use a highlighter this time. So the graph is decreasing starting here and all the way over because that goes on forever. So it is decreasing from this, which is 2, to infinity. Over which intervals is it constant? And that would be a straight line. So in this case, we don't have any. Okay? Finding these intervals of increasing and decreasing seems to be the trickiest part of this whole thing. All right, let's go to another one. So this time we have to graph 3. So graph g of x equals x, where x is greater than 8. So I'm going to pick x values. So I have 8, 9, 10. So when x is 8, y is 8, so we keep these the same. This is 10. I don't know why I won't write on that. Okay, so now we're going to graph these. So I have 8. Let me get some ink here. I have 8. All the way up in the corner, 8, 8, and it's greater than, so my dot's open. Then I have 9, 9, and 10, 10. Oh, there it is. Okay. So the next one I have g of x equals 4 between the intervals of -2 and but less than or equal to 8. So here is my -2, so blue. That means when I draw my table, I'm going to pick -2, 0, 1, 2. I'm going to continue over here. 3, 4, 5, 6, 7, 8. It is 8. Okay, and no matter what, my y is going to be 4. Okay, those are all 4s. So when we graph that, so we're going to start at -2, 4, which is here. It's going to be an open dot here, and we're going to go all the way to 8, 4, which is here. And we have our horizontal line. Okay? So the last one says the g of x of -3/2 x plus 2, where x is less than or equal to -2. So let's make our table. Pick some x values. So it says x is less than or equal to -2. So I'm going to have -2, -3, -4. When I plug in -2 for x, I have -3/2 times -2 plus 2. That's 5. When I plug in -3 for x, I have 6.5. And then I have 8. So let's plot those. So I have -2, 5, which is right here, and it's a closed dot. Then I have -3, 6.5, which is right here. Then I have -4, 8. All right, now comes the tricky part here. Over what intervals is the graph increasing? Remember, we're going to left to right. So it starts increasing right here. And then it goes on forever that way. So it is increasing from 8, and then it goes all the way forever left, so to infinity. No brackets here. Over what intervals is the graph decreasing? So let's get the highlighter out again. So all of this, it's decreasing all the way to here. So we have, let me get a pen, negative infinity all the way to -2. And this here section is constant because the line is straight. So it's constant from -2 all the way to 8. All right, let's do one more. All righty. So the graph of y equals x minus 3 for all the values where x is greater than 7. So we have 7, 8, and 9. 7 minus 3 is 4. 8 minus 3 is 5. We're going to plug that in. 9 minus 3 is 6. So we're going to draw that. So we're going to start at 7, 4, and it's going to be an open dot. Then we're going to plot 8, 5, and 9, 6. There we go. Now we're going to make a table for y equals negative 1/2 x. So all the values that are less than or equal to 7. So we have 7, 6, and 5. Half of 7, negative half of 7 is negative 3.5. Negative half of 6 is negative 3. Negative half of 5 is negative 2.5. So let's graph that. So I have 7 and 3.5. So 7 and negative 3.5. And this is closed. Then I have 6 and 3. Then I have 5 and negative 2.5. Okay, so this one, both of them are increasing over time. Okay, so it is increasing so this goes this way forever. That goes that way forever. So it's increasing from negative infinity to infinity. It is not decreasing and not constant.